Okay, so let's talk about it as usually. But try not to answer all of this. So, well, this is pretty straightforward, right? Plasma versus formed elements and cells. Just know the cells of the blood. RBCs, white blood cells, platelets. Main protein components of plasma. So, there's 5. That's the protein components that you need to know. Function-wise, osmotic pressure, transport, immune function, coagulation. Now, non-protein components, well, respiratory gases, hormones. Now, for urea specifically, remember we mentioned that protein catabolism. Now, red blood cell, biconcave shape. No nucleus, no mitochondria. What are the protein components of hemoglobin? 2 alpha to beta chains. Heme holds the iron, iron binds oxygen. Well, difference between oxy, deoxy. Fairly straightforward. You need to know where these are formed. Like deoxyhemoglobin found in tissues, oxyhemoglobin found in lungs. Stimuli for erythropoiesis. So, remember I gave you the list in one of the questions on the quiz, something like that. So anything that reduces the oxygen availability, hypoxia, iron deficiency, fairly straightforward. What can cause anemia? Anything that will reduce the number of red blood cells. Blood loss can induce anemia. Iron deficiency can induce anemia. Vitamins, 2 vitamins that I want you to know. B12, folic acid. These vitamins are essential for quickly replicating cells. Iron stored and transported by transferrin, stored in a complex of hemosiderin. What happens to the RBC after they expire? They're destroyed by spleen. Sickle cell anemia, thalassemia. What you need to know about these 2 diseases? It's a mutation that leads to altered red blood cell structure. And it provides, a fitness advantage. Protects against malaria. Remember we talked about it? Symptoms, hemolysis, hypoxia, vascular damage, kidney failure, splenomegaly. Now, this is something I think that is very clear. What you need to know, you need to be very clear about what granulocytes and agranulocytes are. And you need to be very clear about the functions and the mechanisms. So, for instance, if I ask you, which of the following granulocytes, listen closely, which of the following granulocytes is a phagocytic cell? And I give you a list. Neutrophil, eosinophil, basophil, monocyte, or even macrophage. You read question carefully and you say, okay, 2 keywords. Granulocyte, phagocytic cell. Which of the list that this fella gave me are granulocytes? Neutrophil, eosinophil, basophil. Does that make sense? So if they are not granulocytes, forget about it. Which of them is phagocytic? Neutrophil. The answer is done. Does that make sense? And so pay attention to the questions. Same is applied to agranulocytes. Now, so mechanism, functions and mechanism of action for the cells. I'm not going to go into molecular details. Basically what I'm asking is, are they phagocytic or not? Can they cause apoptosis or not? Do they stimulate inflammation or not? Am I clear? Cells of myeloid, lymphoid origin. Cells of lymphoid origin are lymphocytes. They seed lymphatic system. Cells of myeloid origin belong to blood. This So, tissue injury leads to release of cytokines and chemokines that promote leukocytosis. Leukocytosis increases the number of white blood cells. Leukocytosis increases the number of white blood cells. Leukocytosis adhere to the endothelial surface at the site of injury and then migrate to the blood vessel wall due to the increased vascular permeability. The process of migration is called diapedesis. The steps are attachment, rolling, firm adhesion. Why did I say 4 steps? Extravasation. Okay. Attachment, rolling, adhesion, extravasation. Right? 2 cell types, macrophages, neutrophils mostly. They find the site of tissue injury following the trail of chemokines, cytokines, positive chemotaxis, role of plasma leakage. It removes the debris and the dead cells. Clotting factors, they trap the pathogens in place. Components, so this one, like redness, vasodilation and increased blood flow, pain, release of chemical factors from the injured tissue and swelling, edema, increased vascular permeability leading to swelling. Pathologies associated with white blood cells, leukemia. This is as far as we go. Am I clear? I'm not going to ask you about different types, just leukemia. Platelets, derivatives of megakaryocytes. Now for the functions. I do not accept the answer that the function is only clotting. They play a role in clotting and in inflammation. And we mentioned that before. Am I clear? Now, steps of hemostasis. You've got vascular spasm, you've got platelet plug formation, and you've got clotting. Am I clear? So vascular spasm is kind of, self-explanatory. Stimuli necessary for the platelet plug formation. Exposure of the basement membrane of the vascular endothelium. Basically, damage to the vascular endothelium. Do I make sense? Basic mechanism of the platelet plug formation. Here's what I want you to know, but I'm not going to be asking you about von Willebrand factor, P-selectin glycoprotein ligand, and stuff like that, which is supramolecular. What you need to know is that platelets get activated when they are exposed to certain molecules in the basement membrane of injured endothelium. That's one. And most important, activated platelets activate other platelets. Does that make sense? So it's a positive feedback. You got it? Coagulation cascades. I will focus way more on the conceptual differences between intrinsic and extrinsic than on the individual steps. So, well, to what extent? If I ask you, factor 12 belongs to intrinsic. Make sense? Like factor 7, extrinsic. Let me be frank. I have no intention of asking you the entire sequence. Like, put these factors in the proper order for the intrinsic coagulation cascade. I can do this. I can exactly predict the moment when you forget all that. That's the moment when you put your scantron right over here. Second later, you don't remember anything about it. But conceptually, yes, I'm going to ask, which one's faster? Which one's slower? Which one requires the exposure to the tissue factor? Obviously extrinsic. Which one doesn't? Does that make sense? And the questions are going to be in the form of, which of the following statements is true or false? So you have to figure out which statement is right. And then, like, which of the following statements about extrinsic pathway is correct? It is faster than intrinsic, slower than intrinsic, requires exposure to tissue factors, does not require exposure to tissue factors. Does that make sense? These conceptual things. Am I clear? So know just which factor is where. Don't get too hung up on the sequence. Second, you must know that both intrinsic and extrinsic cascades, both pathways, they both converge on the activation of the common cascade. For common, you have to know the steps. Okay? So like prothrombin activator. What does it activate? Prothrombin into what? Thrombin. Thrombin, what is its function? So the role of prothrombin to form thrombin. Role of thrombin to activate fibrin, right? From fibrinogen. Fibrin will enforce structurally the clot, which ion is required for successful coagulation? It's calcium. Am I clear? So I promise there will be questions, and moreover, I'm almost giving you out the entire text of the exam. Well, not entire, but so basically, what if I somehow inhibit prothrombin activator? What's not going to happen? You think, okay, what's the function of prothrombin activator? Activates prothrombin. What's the result? Thrombin. So if prothrombin activator doesn't work, what's not generated? Thrombin. Make sense? So you have to be thinking like one step further than just memorization. Am I clear? Platelet-derived growth factor, vascular endothelium-derived growth factor stimulate endothelial repair. Okay, blood flow. Blood flow removes clotting factors. Period. Ano and prostacyclin they prevent adhesion of platelets to the healthy endothelium, preventing clotting. Thrombin and fibrin. Know it. So unbound thrombin binds to fibrin, essentially putting a negative feedback on that whole coagulation loop. Plasminogen activator and plasmin also know the function. So plasminogen activator activates plasminogen, and plasminogen becomes plasmin. Plasmin lyses fibrin, breaks down fibers, breaks down the fibrin threads, so clot becomes weaker. Antithrombin inhibits thrombin. For heparin, aspirin, warfarin, okay, Hirudin, the bigatran. Okay, let's be honest. No questions here. Okay, I'm not going to ask you what is the mechanism of antithrombotic action of Hirudin. It is a thrombin inhibitor, but what's the point? But instead, again, I'm going to ask you this. Hirudin inhibits thrombin. What doesn't happen if thrombin is inhibited? Does that make sense? What is the outcome of that inhibition? Am I clear? Do you understand what I'm saying? Okay. Thrombocytopenia, low platelets, petechia, hemorrhages in the skin. Now, what causes hemophilia A, B, and C? Low levels of the growth factors, mechanisms of disseminated intravascular coagulation, yes. No, you don't need to know which factors. But say if I ask you, is that a platelet deficiency or clotting factor deficiency or vitamin K deficiency? Say, that's specifically clotting factors. Okay, does that make sense? Disseminated intravascular coagulation. Platelets coagulate in the peripheral vasculature, blocking the blood flow, and in the meantime, the blood that is deprived of the platelet and coagulation factors starts to leak into the peripheral tissues, leading to massive hemorrhage. Chemical barrier. Okay. Let me not review chemical barriers found in the skin, digestive tract, reproductive tract. I promise that there's not going to be something super tricky. Basically, what Aaron referred to today when they try to way overthink what happens in the vaginal mucosa. You know, sweat is on the skin, and mucus is on the mucosa, not on the skin. So if I offer you the option mucosal layer of the skin, there's no mucosa. Does that make sense? So just know these barriers. Like digestive tract, mucosa. Lysozyme is in all mucosal membranes, right? Immunoglobulin A found in all mucosal membranes. Okay, physical barriers. Mechanical, mucus and cilia. What happens if the pH changes? It makes the organ more sensitive to the infections. Smoking destroys cilia. What effect would it have on the organism? Mucus keeps being stuck in the respiratory tract, which increases the chances of the respiratory tract disease. Clear? Makes sense? Cool. So it basically harkens back to the story of white blood cells. So as you can imagine, there's going to be a lot of questions on the white blood cells. Make sense? Main differences between innate and adaptive immune responses. Innate, a fast, non-specific, local, not super effective. Adaptive, fairly slow, very specific, systemic, really effective for memory. Phagocytosis is that specific, not so much. Pseudopodia engulf the pathogen. Phagosome takes the pathogen in, fuses with lysosome, forming phagolysosome, and different oxidative chemicals like hydrogen peroxide or bleach and digestive enzymes contribute to the pathogen killing. Main difference between neutrophils and macrophages: die, don't die. Neutrophils die, macrophages don't. Main components of the complement system: proteins, 3 pathways, classical, alternative, lectin. Know what activates each pathway. I will ask you about that. What is common? They'll converge on this one spot, C3b. Okay, so that the factors that lead to activation all converge together. Key outcomes: increased inflammation, phagocyte recruitment, opsonization, and membrane attack complex. So be able to know what membrane attack complex is. Basically, it penetrates the membrane of the pathogen and leads to its lysis. And then opsonization, proteins of complement surround the microorganism, making it more attractive to the antibodies, to the phagocytes, I'm sorry. Interferons, proteins produced by infected cells, 1 and 2 types. What triggers? Well, infection. Interferons interact with a receptor. When interferon binds to the receptor, there's a sequence of intracellular events, okay, that stimulate production of protective responses. Basically, cell is being primed against the infection. We do use interferons for the medical treatments. Medical use is limited because of the side effects. Unique features of adaptive immunity. We mentioned it: specific, slow, forms immunological memory systemic. So I can give you a description of something like response that involves multiple organs and systems and reaches virtually every corner of the human body. That's systemic, right? Does that make sense? Something like that. Humoral and cellular response. Know the difference? Humoral is mediated by antibodies. Cellular response is mediated by T cells. Know they are originated. Know where they mature. Know where they go. Know what happens with them there. So basically, I ask you, where do B cells encounter pathogen? Tell me, in the lymphatic tissue, because that's where they are. Does that make sense? Or where do T cells mature? In the thymus. Am I clear? Now, B and T cells, when they recognize the pathogen, that they relocate to the circulation and start responding. Antigen. I give you a list of molecules. You tell me which one is antigen or isn't. Antigen is the large and complex molecule. Antigenic determinant is a fragment of that large and complex molecule that your immune system actually recognizes. Haptene is the small molecule that cannot produce immune response by itself, but can if it is attached to a larger carrier. B cells can recognize the pathogen directly. B cell receptor is necessary for this recognition. B cell receptor consists of two heavy and two light chains, and each B cell receptor, as in any antibody, has FAB fragment that recognizes an antigen or antigenic determinant, and Fc fragment that binds to some kind of a cell. Clonal selection, okay, we discussed it. Everybody's clear about clonal selection. It's the process of antigen recognition. What follows clonal selection? Clonal expansion. That's the proliferation and differentiation of B cells. Does that make sense? So we call the entire population of B cells with the same receptor, so B cell clone. And B cells differentiate into plasma cells that produce antibodies. For antibodies, you need to know 5 types. Any questions on those 5 types? What's the extent of functions? Which one can cause placenta? Which one is secretory? Which one causes allergy? Which one B cell receptor? I promise that's basically like, I'm not going to ask you which one is more abundant. Oh, and which can activate complement. So, IgG, IgM activate complement. IgG crosses placenta. IgA, secretory. IgE mediates allergy. IgD, B cell receptor. It's basically it. Does that make sense? Do antibodies play any role in the innate responses? Obviously, if it follows by the question how, the answer is yes, they do. 2 things. First, they can activate complement, right, by a classical pathway. And they, remember, we talked about opsonization. So we mentioned that complement proteins can opsonize, and antibodies can opsonize as well. So antibodies can make a microorganism or pathogen or anything more prone to phagocytosis, kind of increase the availability of that pathogen to macrophages so they can destroy it better. So that's the link between the humoral response and the innate. One link is complement activation, another phagocyte recruitment. What happens during primary B cell response? Antibodies go up and then go down and produce memory cells. When secondary exposure happens in the secondary immune response, remember, the levels of the antibodies are much higher than in the primary. Does that make sense? Now this one, types of humoral immunity. Vaccine is an example of artificial active. Since infection is an example of natural active. Am I clear? Main mechanisms. We have this huge picture, the flow chart with mechanisms for antibodies. Basically, you need to know what precipitation is, neutralization, agglutination, how they can fix complement, what are the outcomes of the antibodies. Remember, again, I remind you, if I ask you what can opsonize a pathogen, you can tell me it's complement or antibody. Does that make sense? Not only one of them. Complement can opsonize, antibody can opsonize. Now, how antibodies link adaptive and innate responses, we already answered that question. Complement activation and increased phagocytosis. So for MHC, so it's a protein complex on the surface of the cell that presents antigens and allows your immune cells to recognize self versus non-self. It's the function. Difference between type 1 and type 2. Type 1 are expressed on all nucleated cells. Type 2 on antigen-presenting cells. Okay? So, we answered this already. Produced in bone marrow, mature in thymus. Where do they get exposed to the antigen? In the lymphatic organs, they go in the circulation. For antigen recognition by T cells have to be presented with an antigen. And they're presented by antigen-presenting cells. To functional types, so remember we talked about CD8 and CD4 cells. CD8 cells recognize type 1 MHC, and CD4 recognize type 2 MHC. That strict recognition pattern is called MHC restriction. And immunological differences, so CD4 cells or helper cells stimulate phagocytic activity of macrophages, stimulate the differentiation and proliferation of B cells, so they activate B cells, and they help to activate cytotoxic lymphocytes. Okay? T regulatory cells dampen the immune response, and if Treg production is impaired, you have autoimmune diseases on your hand. Cytotoxic T lymphocytes. Okay, so for this, you have to know that CDLs and NK cells, which are very similar mechanically, they do not phagocytose, they do not produce antibodies, they do not release respiratory burst. What NK cells and cytotoxic lymphocytes do, they either can release perforins and granzymes, leading to apoptosis, or they can induce apoptosis by ligand-receptor interaction, fast ligand, fast receptor interaction. Does that make sense? So they cannot phagocytose. Now, humoral response links adaptive and innate. We already talked about antibodies can activate complement and increase phagocytosis. Cellular response. CD4 cells, helper T cells, increase the activity of macrophages, linking adaptive and innate immunity. Now this part. Examples. Type 1, allergy. Antibodies, immunoglobulin E, bind to mast cells. At the second exposure, basophils mast cells degranulate. Symptoms, runny nose, hives, Anaphylactic shock, massive degranulation and release of histamine systemically, which leads to massive vasodilation, bronchoconstriction. So vasodilation leads to the pressure decrease, bronchoconstriction leads to suffocation, asphyxia. Type 2 hypersensitivity. We discussed in class only one example. Transfusion reactions. Know it. So, you need to know blood groups A, B, AB, and O. Am I clear? You need to know or understand what you can transfuse to what. So you can get a question something in the same way that you've got one here today. Does that make sense? Am I clear? Remember that agglutinogens are on the surface of the red blood cells. Agglutinins are in the plasma. Mutually exclusive, meaning that a patient with AB blood has no agglutinins in the plasma. The patient with O blood has both A, anti-A, and anti-B agglutinins in the plasma. Know the general idea of transfusion reaction. Refer to this. So, hemolysis, hypoxia, kidney toxicity. Blood type is universal donor, O negative. And remember, since we talked about both ABO blood type and rhesus blood type, I expect you to know that the universal donor is not just O, but O negative for these types. And universal recipient, absolutely universal, is not just AB, but AB positive. Good? Now for rhesus, know the mechanism of rhesus conflict. Okay? The name of condition, erythroblastosis fetalis or hemolytic disease of newborns, how it is formed. Something like, you saw the question today, like when the exposure happens. Which blood types should be in mother and child? Mother's Rh negative, child Rh positive. Know how ROGAM antibodies work. Am I clear so far? Type 3 hypersensitivities, know that it's mediated by IgGs, by the formation of immune complexes associated with the basement membranes in epithelia cells. Neutrophils and macrophages destroy those basement membranes, epithelium fails. We actually discussed, we discussed two. It was rheumatoid arthritis and lupus, systemic lupus erythematosus. Type 4, know the mechanism. Exposure to an antigen, development of cellular response. Second exposure to the same antigen, cytotoxic T cells and macrophages start to attack the antigen, which leads to inflammation, local inflammation. So we call it delayed because it's T cell mediated. All right. So cells that cause cytotoxic response are macrophages and cytotoxic lymphocytes. It's called delayed because it takes time. Two types, TB test and poison ivy reaction. Auto-iso-allo-xeno transplantation, know what it is. Rejection, immune system of the recipient rejects the solid graft, attacks the solid transplant. In graft versus host disease, immune system generated from the donor's bone marrow attacks the tissues of the host. Immunodeficiencies. Be able to distinguish congenital and acquired, and know in terms of congenital that in DiGeorge syndrome, cellular immunity is affected. In A-gamma globulinemia, humoral immunity is affected. In SCID, both branches of adaptive immunity are affected. Lymphatic system draining, Okay. Anatomical parts. So no, the capillaries, collecting vessels, ducts and trunks. That's basically here. 4 main types of lymphatic vessels. Lymph contains some plasma proteins and debris and dead cells. Anatomical parts, again, lymph nodes, spleen, tonsils, Paris patches, stuff like that. So we've got vessels. They empty into the blood. What propels lymph? Muscular pump, respiratory pump, contraction of the nearby arteries, and weak constriction of the smooth muscle in the walls of the lymphatic vessels. Which cells you can find in the lymph node? Macrophages, T and B cells, reticular cells that produce reticular fibers. Loose reticular connective, it filters, it's a mesh. Main layers of the lymph node, medulla and cortex. Now, cell distribution, I'm not going to focus too much on that. Basically, you have more B cells in the cortex, more B and T in the medulla. So afferent vessels deliver the lymph into the node. Efferent are the draining vessels. Remember why the flow is the stagnant, because you have more afferent vessels, the incoming vessels, than efferent. Function of spleen. It can produce red blood cells, it can produce platelets, and it can produce monocytes and other white blood cells. All cells that are recycled, virtually all cells of the blood can be recycled in the spleen. Okay. Red and white pulp. In white pulp, so white blood cells, and red pulp, it's the red blood cells. Sinusoid capillaries are the most abundant. In the spleen, thymus, maturation of T cells, anatomical layers, cortex and medulla. Thymus is separated from the blood to avoid the generation of T cells that will respond to our own antigens. It is separated by thymus blood barrier. MALT, mucosa-associated lymphoid tissue, found in the respiratory tract and digestive tract. Paris patches, specific MALT in the digestive tract. Tonsils, respiratory tract. That's kind of it. So I can tell you this. Lymphatic system, very small part. Really small part. Blood and immunity. I would say immunity takes a little bit more space than blood. I genuinely cannot tell you the exact numbers of questions in each chapter, but it kind of gives you a distribution. Immunity will be the most questions, blood will be the second, and they will be very close, and then lymphatic there's going to be only few. Am I clear?